Hey guys, this is Mainak. Welcome to the video. Today we will design a mat footing using the results obtained from the Staad Pro. So we have designed and analyzed the building fully in Staad Pro, and we want to design a mat footing for this building as the soil bearing capacity is quite low, which is 80 kN per meter square. So we'll provide mat footing here, and when we design the isolated footings, most of the footings overlapped as the soil bearing capacity is low. So then we are going to design the mat footing. So the first step, which will be, we will import all the data into save the data of the coordinates of the columns or the bottom of the columns or the supports. So we'll copy the coordinates first, and then we'll copy the loads from the stat file, and then the usual process of designing mat footing in the save. So we'll do that. Let's proceed forward. Okay, so now first of all we need the coordinates of the base in from stat. So for that we'll go to view and front view in the stat profile, and we'll select the node cursor, and we'll select all the nodes of the supports. And when all the nodes are selected, you can see in the geometry all the nodes will be selected. So right click and click on copy and open MS Excel or any spreadsheet program. I'm using WPS Office here, and we'll paste it here. So when we paste it here, and you know that first coordinate is x, and then it is y and z. So y and z are interchanged in ETABS and Staad. Instead, by default the y is up, and in the ETABS by default z is up. So we'll just interchange this. Okay. So simply we'll interchange this thing. Okay, so the coordinates are copied. Firstly we only need the coordinates, so let's do this first. Okay, so we'll go to save and new model, and select your code as per 56. We'll select India's code, and first of all save the model. Okay, so save the mat 2, I'll name this, and click on save. So this is saved. Now we need to import the coordinates. For importing the coordinates, we'll go and go to edit interactive data modeling, expose all tables, geometric data, point coordinates table. Okay, click on OK. You can see the table. Okay, so the units are not set here. Okay, my bad. So in the starting itself, we can set the units. So I forgot to just change that. Do that in the startings here. So if you forget, then you can go to options and go to units and metric defaults and click on OK, right? And then you can go to edit interactive database modeling, geometric data, close all tables, point coordinates, meters. Now it's in meter, so you can just observe this. So first is point, so 1 2 3 4 we can give, then is the x, y and z coordinate, then special point yes or no. Okay, simply we can just see this, whether the format is okay, and special point yes, I'll just do this yes and then drag it to the entire thing. Okay, then I'll copy this. Okay, all the 48 points, will copy this, Ctrl plus C, then I'll select this cell, and then Ctrl plus V, it will paste. Then I'll apply to model and click on done, and then it will not be visible. To make this visible, set display options, untick this invisible, and then click on OK. So this is visible now, right? So the next thing which you need to do is define materials. So let's see what is this material. This is tendon, so this is not required. This is concrete, so just do this M30. Since minimum reinforcement grade is M30 here, so you can change the grade here and click on OK. And let's see what is this one here. Next one, this is rebar, so just do this AFE 500, and you can change the properties of this. Okay, and click on OK, then click on OK here. You can also check the internet and check the properties of 500 and M30. We've done that. So then we go to slab properties. Slab 1 itself, we will just rename this. M30 is there, and the thickness of the slab will take as 500 mm. Okay, click on OK and click on OK again, and then we go to reinforcing bar sizes. Can select the common set from SI. Okay, clear all bars and select the common add bar set. Okay, and click on OK here. and then you go to column properties. So all the columns here in Staad are 500 to 500, so you don't need to worry about this. Simply just do 500 into 500 and then click on OK. Click on OK, and then you go to define, and then we don't have any wall, so I'll subgrade. Obviously we have just modify this, and subgrade modulus we will change. So subgrade modulus is simply, you just open the calculator. So the soil bearing capacity is 80 divided by allowable settlement. Let's take 45 mm, so 0.0, or up to 50 mm also you can take. Let's take 50 mm, okay, 0.05 for 50 mm for normal mat footing, and for isolated footing it is 25 to 30 mm. So 0.05 50 mm and click on OK. So it is it will be 1.6 into 10 to the power 3, okay, 1.6 into 10 to the power 3. So let's do this, 1.6 into 10 to the power 3 and click on OK. So we'll need a soil test report for this, right? Then what is remaining, you see, coordinate system already have defined, mass source etc. will define, load pattern will go later. Let's just finish this column assignment, okay? So load part will go later, okay? So here you have the column here, and only one you have defined, so no need to select, just simply you can assign here, automatically that property will be defined. So let's click here. If you don't have grades, we have to like click on one. If we had grades, you could just drag and all the columns would be there. So that's the downside of not having grades. But again, if you work in the same company interface, like if you import from CSI software to CSI, then it's easier. Like all these steps are not necessary there. Like from ETABS to SAFE if you import, or from Staad to RCTC, or Staad to Staad foundation, very minimum steps are required. But this goes across company software, so that's why steps are more. Okay, so I've defined the columns here. Now it seems that we can go to the loading part, right? So before going to the loading part, I want to do some steps in Staad Pro. So let's open the Staad Pro. Here we'll go to post processing, and let's first of all just select the loads which we want. Here in the post processing, we want all the primary loads, and click on apply and click on OK. And then in this table, right click and then click on our support reaction table. Support reaction table will open up, and then just click on this and click on copy. Okay, after you click on copy, open your spreadsheet file and then click on here and click on paste. So now already know that these are interchanged here, this and this, Y and Z. So just interchange this, Control X, let's do this, Control V, Control X, 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 Control V. So this is done. This will be actually F5, and this is actually F7. We just change the position. Okay, this will be MY in save, and this is Z in save. So this is done, and name. Look at the name of the load here, because this is very important. Whatever, when you are importing the loads, whatever name will provide here, same name you have to provide in the SAFE software. Okay, simply go to SAFE once again and go to define and go to load patterns. As I told you, load pattern name should be the same for both of these. So here I'll just change the name as this, or you can change this name, or you can change that name. Okay, it says is dead and space dead load. So I can also copy this like this, copy, and yeah, I can do this also, copy the entire thing, Ctrl plus C, and then I can just paste it here, dead load, and this one is live load, right? The order is not important, only the name should be the same, right? Live load, Ctrl plus C, and save, and Control plus B, add new load pattern, add new load pattern, add new load pattern, right? Now this just to copy from here, X response spectrum, okay, X response spectrum, copy it here, it will be X response spectrum, and then we need to do a change here because again we know the X and Y are interchanged here in Staad and this, so we'll just Y this one, Control plus X, or simply I'll just change this X Y Z, right? So 2 will be Z response spectrum and capital Z, let's give, and this will be Y response spectrum, right? Y response spectrum. So X response spectrum has been copied. Now Z response spectrum is 2. So this is response spectrum load, only the earthquake load in X, Y and Z direction which is applied in the software. Whatever, if this is different in Staad model, just copy the earthquake load, okay, in your Staad for your particular Staad model, okay. No need to just get confused. Whatever the name is here, same should be in ETABS. That's the concept. Whatever you name of the earthquake load you have given, EQX, SLX, just copy and paste. If you have not given Y, not necessary, okay. Only 2 directions is enough. In this particular file I have given 3 directions. So this is added, and click on OK. Load pattern have been defined. I'll define the mass source, dead load, and then the live load, and the scale factor will be 0.5 since live load is more than 3. Okay, since click on OK, and then what you need, define load patterns and load combinations also. Add new combo, not default combo, will add service initial ultimate, let's say everything, and then click on OK, right? And then you go to, you can add manual combinations also, and then you go to, we'll add the loads. We have to add the loads, so we'll go to edit, and we have to go to interactive database modeling, expose everything. Don't need geometry now, we need assignments, and in the assignments we need load assignments in the form of point loads. Click on OK. So you just want to see the table here. So this is text, load pattern text, and then fx, fy, fz, mx, my, mz. This is OK. And then x dimension, y dimension. Okay, x dimension, y dimension is for the columns, right? So let's go to the Excel file and prepare this. Okay, only this thing we have changed, so this thing we have to paste in everything, right? All the coordinates we have to paste since we have interchanged the y and z in this. So we have to do this step. We want to change this order. In all the files. Total there are 48 points, so in 48 places you have to do this. Okay, then the next thing which you need to do, this node number you have to copy in this portions also, right? Copy, select this, paste, or in Excel you can simply drag, but in here this WPS spreadsheet we have to do like this. So just simply doing this. So once we have done that, like and then next thing which you need to add is the column sizes. Column sizes are in mm, so 500 into 500. Select these two and drag this, select this and drag this, right? and then simply, oh, 500, sorry, this actually if you do in Excel, then there won't be any problem, but this WPS sheet you have to copy and then paste. That is better. Right. Okay, so this is done. Now we can copy the node number MX, MY, MZ here, and the load names as well, and here like this. Copy everything up to 48 number, copy and select this and paste it, and apply to model and click on done. So the loads are applied to model here. So we can go to the 3D view and go to display and show loads. Dead load, suppose you can see the dead loads here, and display show loads, show loading values, then to show the loading values as well. Okay, so you can do this. Okay, so loading values can be shown like this. Now the next thing comes, let me just switch back to the 3D view here, and then we will apply the other things. So first of all, we'll go to draw, and here we have this. We can also draw rectangular slabs, right? Like this, rectangular slabs we can draw. Okay, let's just do this. Single click here, and then don't leave your click, and single click here, and then you can kind of select this and go to edit, and edit areas and expand areas, offset value 1500 mm, click on OK, and more 500 mm which we have to increase to put this also. So select this and edit, edit areas, expand areas, more 500 mm, let's increase, click on OK. Okay, now it's perfect. 500 minimum offset is there in all sides, so this area has been done. So now let's just select this and assign slab data properties. Okay, slab 1, you can see, again select this and select this slab, and then assign support data soil properties, click on OK. Soil properties have been assigned, slab properties have been assigned, load has been defined, load combinations have been defined. Now next thing is the design steps. So go to draw. Now we don't have any grids here, so if you have grids we could have done the design steps automatically also. So there are two options: you can either draw grids or either draw your design steps. Okay, so draw grids. So you can draw grids like this, and you can then draw the design strips. Then automatically assign the design strips from this option. You have this edit design strips, and you can draw automatic design strips from here. But now we'll just draw some design strips just to take the design here randomly. Okay, so you can go to draw, and simply we'll draw design strips, and let's keep the width here, no problem in that. Okay, and we'll draw some design strips here. So here to here, let's draw one, and draw design strips from here to here, from here to here. Right, if you right click, then this program actually ends. So just doing that, right click, and again select this, select left click first and then right click, and then again select this like this, select this, right click. And at the end let's draw one design strip here, select this, right click. So design strips have been drawn in this direction, and let's draw V in the other direction, like this direction. Okay, right click, left click, left click, right click. Right, I think this line is not straight. Control Z. This one is also not straight, right? Control Z. Okay. Left click, left click, right click, left click, left click, right click. Okay, so then just close this. Okay, let me give another one along the middle. Draw design strips in the middle. Let's give midpoint to midpoint. Okay, so this is done. Design strips have been added, and you go to run, and run analysis and automatic slab meshing options. You can just mesh the slab here. If you, the more minimum you do, more accurate it will be, but the more time it will take. So let's, for this purpose, let's just take 0.8 here and then click on OK. Okay, and then design, run. So in the run you have the advanced sapphire options as well. Okay, so you can easily change the solver type as well. So analysis type also you can change. Okay, and then cracking analysis option you can take, but for now let's go to analysis and design. Okay, so it will take time, as I told you. So the lesser grid size you give, the more time it will take and the more accurate it will be, right? So we can see the analysis results are complete here. So this shows the displacement here. You can also see this in the 3D view as well, the displacement. Okay, and if you go and display the strip forces, suppose any strip forces you just want to see, you can also see if you want to show the values. You can also see show the values of this moment and shear force also. You can see strip forces, and if you want to display the deform shape, reaction forces, slab stresses, you can see the slab stresses here for all the forces and moments here. You can see that. Okay, and then if you want to see the slab design, which is the main thing. Okay, before that let's go the punching shear step. All are below 1, so it's okay. So if you want to see the slab design, so show slab design. You see there are two strips, layer A and layer B, and click on apply first of all, and you can see this is the top and bottom reinforcement in mm square. It is showing, and I'll just impose minimum reinforcing and click on apply first. So minimum reinforcement will be imposed here. So you can see the 750 mm square. So suppose this is 750 mm square at the bottom, means if we apply like for area of a 12 mm bar is 103 and the area of 16 mm bar is 200, from that we can calculate the spacing required. Okay, from here, so I'll just show you an example of how to calculate the spacing, but let's see like this. And if you go layer B and click on apply here, you can also see the AST for the top and also the AST for the bottom here. We can see that. So we can see the top and bottom rebar here, and then we can also go to the detailing also, and you can see the detailing sheets also, drawing sheets. Go to detailing, run detailing. Okay, so drawing sheets, let's see the drawing sheets generated. Okay, you can see the rebar plan here. So from the HT you can calculate the HT, and you will find the rebar plan here of the the bottom. Obviously the rebar will go all through. In the top, all the extra rebars, you can just see the length from here, and the top rebar plan also you can find it here, right? And this is the spacing, and this is the number of bars, and then slab framing plan also you can see this, general sheets, general notes, list of drawings. So everything you can see on all the checks are here, and which you can do. Okay, suppose the minimum reinforcement which is coming here is 750. So we'll do, how we'll calculate the spacing of 12 mm bars. So 12 mm bars we will do 5 and 12 square, that is 1 and 3. So the area of 1000 for 1 meter distance we'll see into 113 is equals 11300 divided by 750 will do, and we'll get a spacing. So if you provide 12 mm bars and spacing of 150 mm at the bottom, then it is sufficient. Similarly for the top also you can calculate like this using the HT. So depth of the slab is 500 mm, and the bars, if you just take the average, take on an average bars, if you provide 12 mm bars, a spacing of 150 at both the top and bottom, then all the most of the criteria will be satisfied here. So like this you can calculate the HT of the slab also. So thanks for watching, keep learning, bye bye.